Hi, today I want to go through lesson 7 so that you may be able to do the homework that I assigned today. So remember, the assignment is due on Sunday and not tonight on Thursday. So going straight in, today's goal is to learn how to use statistics. So you need to understand that a representative sample can be used to draw conclusions about average characteristics and variation within a larger sample space. So let me just share the screen. I just realized I'm not sharing. Okay, now I'm sharing. Okay, so I said the goal is to understand that a representative sample can be used to draw conclusions about average characteristics and variation within a large group, because the fraction of members within a common characteristics is approximately the same in the sample and the larger group. So let's look at terms that we're going to encounter in this class, in this lesson. We have population. So a population refers to the entire set of individuals, objects or events that are subject of interest for a particular statistical study or analysis. So for example, if I was analyzing your class, if I wanted to know about the age characteristics of your class, your entire class of 25 or 27 people, that is an entire population. But if I take 5 students or 7 students from that class randomly, then that is going to be a sample of the population. So a sample is a subset of individuals, objects, or events selected from a larger population for the purpose of research or analysis. Frequency refers to the count of occurrences of a particular event, value, or category within a dataset. I explained this in class. And here we have mean absolute deviation. This is the measure of dispersion or spread of a set of data points. It measures the average absolute distance between each data point and the mean of the dataset. So as I had explained in class, this is the absolute difference between a given data point and the mean. So that means it has no sign. So let's look at the launch problem. The dot plot below shows the price per pound of catfish from all the different fishermen at a market. So specifically, I want you to understand how I found the mean and the mean absolute deviation. So what we have here, price per unit, this row here, this is specifically these data points that I get from our plot. So don't be confused where these numbers come from. They come from this. And the frequency, as I said, frequency is the number of times a given data point occurs. So these frequencies are numbers that come from just counting the number of dots for each occurrence. So it's basically just the occurrences. And so on and so forth. So to find the total amount of a given data, you have to multiply the given data point and its frequency. So if I'm in this column here where I have total price per pound times frequency, I just multiply the given data point, for example, 1.6 times 2. So I have here 1.6 times 2, and I get the total as 3.2. Then I multiply 1.7 times 5. I get the total as 8.5. Again, I multiply 2.8 times 1. I get 2.8. I multiply 2.6 times 2. I get 5.2. After doing that, I add all the totals and I get the total to be 39. And I know I have 20 data points. So I calculate the mean. And to calculate the mean, I divide this total 39 over the number of occurrences, the number of data points that I have. And that gives me a mean of 1.95. Now that I've found the mean, I need to find the deviation. So the deviation, again, as I had said, this is the difference between the mean and a given data point. So starting with this first data point, 1.6, and I subtract the mean, I get negative 0.35. Again, I subtract the mean from the second data point, which is 1.7. So 1.7 minus 1.95, I get 0.25. So I continue doing that for every single data point that I have on this graph. The next step is to find the absolute value of the differences, of the deviations. So if you notice here, I drop the negative sign from here and drop the negative sign from here to just have a number without any sign. I do the same thing here. I drop the negative sign, and all these numbers I've also dropped the negative signs. After doing that, then I'm going to find the total deviation. So to get the total deviation, remember, so for example, for this data point 1.6, there are two of them. So to get the total deviation, I'm going to multiply 2 times the absolute deviation. And to get the absolute deviation for 1.7, I'm going to multiply 5 times 0.25. And to get the absolute deviation for data point 1.8, I'm going to multiply 6 times the deviation 0.15, and I get 0.9, and so on and so forth. After doing that, then I'm going to add all the total deviations, and I get a total of 5.7. So now I have a total of all the deviations to be 5.7. To find the mean of the absolute deviations, I'm going to divide the total, which is 5.7, divided by the total number of data points, which is 20. So this 20 here. And that gives me a mean absolute deviation of 0.285. So in the next slide, I've explained what all these terms mean. So for example, I explained what the price per pound is. That is something you get directly from the graph that have been given. And the frequency I've already explained, that is the number of dots per price, that is the frequency column. Deviation, I've already explained that is the difference between the price of a given data point and the mean, and so on and so forth. Send me an email if you're confused. So let's go to the next part of the launch. So the launch was actually asking, these 3 data plots represent samples from this population. So we are talking about this population here. So we need to, the first question we have to answer is, which sample is the best representation of this population? Explain your reasoning by considering the mean and the mean absolute deviation. So what we need to do is to calculate the mean for each sample. So remember, a sample is a few data points from the population. So that means all this sample 1, this is data from this population here that we were given. So let's find its mean. So to find its mean, you add all the points. So we have 1, 2, 3, 4, 5, 6 points. So add their total and you get, then divide by 6 to get a mean of 1.867. For sample 2, find the mean. We have 1, 2, 3, 4, 5. So we have 5 points. The total is 10.2 divided by 5. You get a mean of 2.04. For sample 3, you do the same thing. You have 1, 2, 3, 4, 5. You have 5 points divided by, so that gives you a total of 12.5. So divide 12.5 by 5, you get a mean of 2.5. So now that you have all that information, now you need to calculate, now that you have the means, you need to calculate the mean absolute deviation. So remember, the mean absolute deviation is basically the difference between a data point, then sum of the absolute difference, then sum of the absolute differences, then divide by the number of data that you have to get an absolute, to get the mean. So we are going to do the same here. So we know the mean is 1.867. So this is the mean, and these are the data points. So if we subtract all that and then divide by 6, we're going to get a mean deviation of 0.2446. And if we do the same thing for the second sample, where we subtract the data point from its absolute, from its mean, we get, this is the absolute deviation, absolute deviation, absolute deviation. So we add all the deviations and then divide by 5 the number of observations, and we get a mean absolute deviation of 0.288. We do the same thing for the third sample. We know that our mean is 2.5, so we are going to have 2.5 minus every single data point, and we get these absolute deviations, and we add all the absolute deviations. We get 1, then divide by 5, and we get a mean absolute deviation of 0.2. So now, which sample is more likely to be a representative sample of our population? So let's look at what I had here. So sample 1 has a mean of 1.867 and a mean absolute deviation of 0.446. And I said this sample is not a good representation of the population because although its mean is close to the population's mean, the difference actually is only 0.083. Its spread, or its MAD, is relatively bigger, which is 0.04404. So we are going to eliminate this. If you look at sample 2 has a mean of 2.04 and an MAD of 0.288. And if you look at these numbers, they're very close to what we got. And the difference between the two means is only 0.09. And the difference between the mean absolute deviations is actually the smallest. So compare these two. You see, sample 2 has a smaller mean absolute deviation. So that's why it is, this sample is more likely to be a representative of the population. Why do I say that? It's because the difference between the mean of the population and this sample is small, which is only 0.09. So very close to the mean of the first sample, but its mean absolute deviation is even smaller. And so for that reason, this sample is likely to be a more representative sample. For sample 3, it has a mean of 2.5, and this mean of 2.5 is relatively bigger compared to the other two samples. It has a difference of 0.55, which is frankly quite huge. But for the its MAD, mean absolute deviation, is 0.2, and this 2 is quite big compared to the other two. It is the difference between its MAD and that of the population is actually quite huge. It is 0.85. So if you compare it with others, it is the biggest. So for that reason, sample 2 is likely to be a representative sample of our population. Anyways, the point of this video was to show you how to calculate the mean absolute deviation, because that's what you're going to work on for this assignment. Good luck.